Hi, everyone. I'm Jim Curry, Intel's Market Development Manager supporting Microsoft. In today's session, we're going to learn about Azure Confidential Computing and how you can utilize it to protect your code and your data in the cloud. Today, we've got a great panel of experts to help tell us how. Graham Burry from Microsoft, Richard Searle from Fortanix, and Bob Rogers from UCSF. Graham, over to you. Please tell us a little bit about confidential computing.
Thanks, Jim. We'll give a quick overview of confidential computing here, and you can always learn more about what's new in confidential computing in the on-demand session as part of Build. To start, we see many organizations are realizing the benefits of scalability and cost savings when moving to the cloud. Still, some companies are holding back specific workloads where they process quite sensitive data, either company secrets, customer information, or any other data deemed too risky to expose outside of a company's walls. Let's consider this from a data lifecycle perspective. There are standard solutions for protecting data at rest and in transit, such as TLS. Gone are the days where you browse the web and see HTTP as HTTPS has become the new standard. Building on top of these existing security and data protection mechanisms in Azure, confidential computing adds a further defense in depth to also protect data while in use. Confidential computing completes this data lifecycle and protects against privileged admins, insiders exploiting software vulnerabilities, so you can be in full control of your data when bringing even the most sensitive data to Azure. With confidential computing, we aim to enable the Azure cloud as a place where all of this sensitive data can be securely queried, analyzed, even combined with broader data sets without giving access to unauthorized individuals, thus moving from computing in the clear to computing confidentially. We see different customers with different use cases coming with all sorts of needs. So from a security posture perspective, there's needs around trusting as little code as possible right down to the application, or having code that can be audited and available through open source. As well, needs where management and deployment options need to be across virtual machines, containers, or even more. Thus, with Azure Confidential Computing, we're aiming to provide the most flexibility with a broad range of offerings to tailor to these various customer needs. For example, we offer services in Azure to provide attestation and secure key management, both of these running on top of our Azure Confidential Computing infrastructure. These are also critical components when building a confidential computing solution. So you can come to Azure and use these different components and be in full control of your solution. Or we also have a growing ecosystem of partners who do this heavy lifting for you, so you can just bring your applications as is and get the full benefits of confidential computing on Azure. One of these partners is Fortanix. So I'd like to introduce Richard from Fortanix to help us understand what Fortanix does in order to enable customers on confidential computing in Azure.
Thanks, Graham. It's a pleasure to be taking part in Build, and I'm going to talk to you about how Fortanix has been working with Microsoft Azure and Intel using their Intel Software Guard extensions technology to provide security via Azure for the UCSF Beekeeper AI project. So Fortanix provides data security, and our mission is to solve data privacy and security for the cloud. And this is in response to increased volumes of data and an increased complexity in the data environment that people are trying to manage today. We do this by providing a centralized control plane for all of your data across the cloud, software as a service, databases, and more. And this is all provided using APIs to enable interaction with the security services programmatically, as well as through a single pane of glass UI. The challenges that people are facing today are based on increased cloud-scale data security issues. These are some headline numbers that should be familiar to people in the audience, where we see an increase in the data volumes that are projected to grow through to 2025. We also see an increased amount of enterprise data migrating to the public cloud using services like Azure. And we see an increase in the privacy regulations that are governing those data assets. And this is the problem that needs to be grappled with, where people are putting their data and workloads into the public cloud environment on what would otherwise be regarded as an untrusted compute resource outside of their organizational perimeter. Confidential computing is being defined by the Linux Foundation's Confidential Computing Consortium as the protection of data in use by performing computation in a hardware-based trusted execution environment. And this is one of the principal technologies that people are looking to provide applications and data security within cloud services, and is the basis for the Azure Confidential Computing resources. The way that Fortanix deploys is that we have a service called Confidential Computing Manager that enables management of trusted execution environments using Intel Software Guard extensions on resources provided by Azure, including DCS v2 virtual machines and the Azure Kubernetes service. This can be integrated with our self-defending key management service to provide the end-to-end data encryption that Graham talked about, with data at rest, data in transit, and data in use being protected from end to end. This also preserves the data and applications within the enclave to prevent access from either the virtual machine manager, the operating system, or any privileged root users or peer applications on the same compute resource. An example of this in practice for UCSF's Beekeeper program shows on the left-hand side an unprotected workload running unsecured, where a simple memory scraping attack can recover what we've programmed in as an extreme secret key. On the right-hand side, however, using Intel Software Guard extensions with Fortanix, you can see that the memory is completely encrypted and the recovery of the extreme secret key through the memory scraping attack is not possible. The information that's shown in the memory dump on the right-hand side only relates to the Fortanix deployment, which is non-sensitive and of no value to an attacker. Fortanix is integrated closely with Microsoft Azure and is available today through the Azure Marketplace and also as a managed application through the Azure portal. It also integrates closely with Azure services to enable deployment of confidential computing in a seamless and simple fashion. Let's look at how Fortanix deploys with Azure in the confidential computing environment. First of all, we need to deploy our software as a service called Confidential Computing Manager. And within the Azure portal, you can search on Fortanix, and from our listed services, select Confidential Computing Manager. We then elect to create a new instance, and we select the resource that we want to allocate Confidential Computing Manager to. We're going to deploy this in the East US region, and we can provide an application name for reference. Once we've provided the name, we can elect to create the resource by agreeing to the terms and conditions. And this deploys automatically from within the Azure environment. Here you can see that Confidential Computing Manager is now being deployed. And once it's deployed, we can see Confidential Computing Manager within our resource group and access it from the Azure portal via the menu on the left-hand side. We can then sign into Confidential Computing Manager via the integration with Azure Active Directory. Here, my colleague is going to sign in using his Active Directory account. He's going to accept the permissions, and then he's presented with the accounts in Confidential Computing Manager that he can work with, and this takes him to the dashboard of the particular account he wants to use. We can then enroll a new confidential computing resource using an Azure DCS v2 virtual machine. This again can be done via the Azure portal by searching on Fortanix, and this time selecting Confidential Computing Node Agent. This will create a new node within our Azure account, and we're going to elect to use the same resource group that we used for Confidential Computing Manager, this time deploying the node in the Canada Central region. We're going to provide some credentials, and we're going to elect to produce a new node, which will be a DC4S v2 virtual machine. In order to do this, we need a join token that's provided from the Compute Nodes pane of Confidential Computing Manager, and this is specific to the account that we're using. We can copy the join token and paste that into the Azure portal, and then elect the attestation method that we want to use. In this case, we're going to use data center attestation primitives to attest the node using Intel Software Guard extensions. Once the join token has been validated, we can then deploy the node within our resource group. And again, this takes place automatically within the Azure environment. Here you can see that the compute node is being deployed. And once deployment is complete, we can see the compute node listed within our resource group. And within the Confidential Computing Manager environment in the Compute Nodes pane, we can see that the new node has been created with an attestation certificate dated the 4th of May. This is now available to deploy applications in secure Intel SGX enclaves. In order to do that, Confidential Computing Manager provides an automated conversion service for programs written in programming languages including Python, C, C++, Java, Golang, and Rust using the Fortanix Enclave development platform. We do this using a containerized deployment, which automatically depackages the container, adds our Enclave OS runtime environment, and repackages the container for deployment with Intel Software Guard extensions. We can also then add labels to deploy the container on specific compute nodes within the Azure environment. Here we can see in Confidential Computing Manager that once we've converted applications, we can use them within a system called Workflows, which associates the application with data sets that are available within our account. Here we'll simulate deployment for the UCSF Beekeeper AI platform to validate some input data and produce a new output data set. We can provide an arbitrary description and then create the new workflow. Workflows are compiled using a drag and drop composition system, and here we'll select the input data set, the output data set, and the application that we want to use to do the processing within Intel Software Guard extensions enclaves. Here we'll select the input data set to be the UCSF input data set. The output will be the UCSF output data set. The locations can be specified to link into the application workflow. And here we'll use the UCSF validation dataset written in Python to do the processing. We select the specific image we want to use, and then select the configuration, which specifies the ports that will be required to connect to the data that we want to process. Using a graph methodology, we can then connect the data sets to the application, here tagging the input data set and linking it to the input port of our application, and doing the same on the output side to link the application via the output port to our output data set. Once we've composed the workflow, we can then save it as a draft and request an approval. And using a quorum approval process, we can request approval where more than one approver needs to provide approval before the workflow can actually be deployed. Here there are two approvers listed. One is my colleague Brian, and the other is me. I can make an approval of the workflow that I composed, but I won't be able to deploy it until Brian has also given permission. Once the permission is complete, we can then deploy the workflow using the compute nodes that we've enrolled. These could include DCS V2 virtual machines in Azure and also the Azure Kubernetes service. This provides a simple and convenient method of deployment. Using Confidential Computing Manager technology that we saw in the demo, I'm delighted to have with us today Bob Rogers from the University of California, San Francisco. And through the Beekeeper AI project, they've been using Fortanix confidential computing technology with Intel Software Guard extensions and Microsoft Azure. Bob, would you like to tell us about the Beekeeper AI project?
Yeah, thanks, Richard. It's really great to be here. At UCSF Center for Digital Health Innovation, we have the privilege to co-develop the world's first ever FDA-cleared AI on a medical device. It's a suite of applications that detect emergent conditions in chest x-rays in the ICU. And while we found that it was a real challenge to develop the algorithms with our data to develop that suite of applications, it turned out that the bigger challenge was actually getting the algorithms cleared with the FDA. The reason is the FDA wants to know that algorithms will work on anybody, anywhere in the country, which means that they need to be validated on data sets covering all different kinds of patients in all kinds of different care settings. And it turns out that's really hard. Data from different locations is different in healthcare. You've got serious security concerns about privacy and about the safety of data. And the effort to build bespoke infrastructure in each location where the data lives turns out to be a huge effort. So at Beekeeper, we developed a platform to change the conversation around algorithm validation and training of algorithms on diverse data sets. Specifically, we said in order to address those challenges that I just mentioned, data must never move. Healthcare systems do not want their data outside their infrastructure. PHI is never exposed nor shared. So patient data is not exposed to algorithm developers. And at the same time, the IP of the algorithm developers is protected and never shared with the data owners. Now, the platform uses confidential computing to bring the algorithm to the data and facilitates all the data transformations, the annotation, and the computing to generate a validation report for that algorithm on that data. The tech stack is really a nested doll of security, starting at the very inside with Intel SGX, which enables a secure computing enclave where the data and the algorithm meet securely. And inside that enclave, a validation report is generated, and that's the only thing that comes out of the enclave. Outside that, we have Fortanix, our friend and partner, who has made it very easy to manage the security and the workflows for all the activities that happen inside the secure enclave. Outside that, we have the Beekeeper stack, where we're managing all the pieces of bringing in the data, transforming, annotating, and making sure that our algorithm developers and our data owners have what they need to bring their assets together in a meaningful way. And then finally, we have our Microsoft Azure infrastructure that everything runs in. It's our HIPAA-compliant confidential cloud infrastructure. And the beauty of that is that we can deploy a Beekeeper node, this entire nested doll, at every location where data needs to be accessed. And the data is secure. We have the ability to run our enclave and create the validation report.
Thanks, Bob. We're really proud to be part of the Beekeeper AI program with our friends at Microsoft and at Intel. What do you think the use of confidential computing is delivering for Beekeeper AI that wouldn't otherwise be possible and has held the innovation back in the clinical space?
Yeah, so this question of being able to protect the data not only at rest, not only in flight, but also in compute, and at the same time protect algorithms in the computing environment is critical. And in fact, doing that in an easy to deploy way, Fortanix can be, as we just saw, very easily deployed from the Azure Marketplace, is a critical factor. The underlying secure enclave technology is complex, so abstracting that all away is fantastic. And then from an Azure point of view, the beauty is Azure is seen as a very healthcare-friendly cloud infrastructure. Azure has invested heavily in creating tools for healthcare broadly that make it easier to do computations for a lot of healthcare applications. The Azure Marketplace allows us to deploy these tools. Azure is the only cloud that we could use to access Intel SGX. And of course, we're excited about the upcoming capabilities with Gen 3 Xeon and the increased capacity and performance of those applications. So what it's really done at the end of the day is make it possible to go from fretting over where's the data going to go and who's got it and how do we control it to the data stays safe, the algorithm comes to the data but isn't exposed, the report gets generated, and the healthcare AI gets that much closer to being validated by the FDA and ending up in the clinic where it can save lives.
That's great. We're looking forward to a really exciting future for Beekeeper AI. Thanks for being with us.
Thank you. And thanks to all our hosts. It's been wonderful.
So that's shown how Fortanix can deploy with Azure Confidential Computing and Intel Software Guard extensions. And now back to you, Graham.
Thanks, Richard. It's truly fantastic, the work by Fortanix and UCSF, showing how confidential computing can help bring data together in Azure with the protection of Intel SGX. Like Bob described, protecting both the data and the algorithms from unauthorized access. Intel SGX provides that application level confidentiality needed to achieve these cross-organization data collaborations. It's also exciting to see the various partners embracing and innovating in the confidential computing space, extending to a broader ecosystem on top of Azure and Intel SGX. We see different solutions across these partners, providing flexibility to companies interested in coming to Azure for confidential computing. We have the specific technology that Intel SGX provides gives that code and data enclave, where everything in that enclave is completely a black box and protected. So even if one company is providing the code and another company or companies are providing that data, they can't access across each other's assets. From this perspective, we have multiple options in terms of how to get started for confidential computing with Intel SGX. There's ability to bring your application as is with a lift and shift strategy. That's what we saw with Fortanix. We have a few companies that allow you to bring your Linux containers as is, Fortanix, Anjuna, Scone. And they're also all integrating with our various Azure services. You saw with Fortanix, they were able to have integration directly in the Azure portal and provide Azure Active Directory single sign-on. It's great to see these ISVs and partners in our ecosystem providing amazing user experiences with integration to meet various customers' needs with Key Vault, Azure Kubernetes services, as well as our attestation services. The other option is you as developers having more control and being able to stay in full control right down to your application, developing with SDKs either from open source projects or some of these ISV partners as well. So examples such as OESDK and Edgeless RT to be able to leverage open source to build your apps, or through a partner such as R3. Lastly, we're seeing these ISV partners directly be able to deploy from our Azure Marketplace. This is where you as a customer and a developer can easily onboard directly through the Azure Marketplace with ready-to-go solutions. Or again, still work in the open source, being able to choose your means and keep control to whatever meets your needs. You saw again with Fortanix that complete Azure portal integration as demoed from Richard. So that was a quick look at our ecosystem. I hope we have everything that can meet your needs and onboarding to confidential computing. Back to you, Jim.
Thank you, Graham. What a great overview. So everyone, if you want to learn more, there's a couple of different options. You can check out the URLs on screen to learn more about Azure Confidential Computing, or you can learn more about Intel SGX. If you want to learn more about Fortanix or UCSF's Beekeeper AI, please go to our partner page. There's a resource section there where we'll have the links. You just need to click on them and you can learn more. So thank you for your time, everyone. We really appreciate it and hope it was helpful. Thank you.